Before we start, I'd like to share a brief disclaimer. White holes are currently considered to be a theoretical concept within physics, so take this information with a grain of salt since none of the properties and behavior are yet confirmed. With that out of the way, let's start.
Imagine you didn't know what a white hole was, or maybe you don't even know what it is currently. With either the former or both being the case, we are here to introduce white holes to you.
So what are white holes exactly? Evil cousins of black holes with more power? Less power? Harsher spaghettification? Or maybe just the same characteristics of a black hole, just colored white?
While answering the question of what is a white hole can't be put simply or explained through a few words, like mentioned, the concept is theoretical and we can only base our information on the current theories.
And since white holes stem from the idea of black holes, you'll have to understand the basic info of black holes.
So it's
Black hole crash course time.
There are many types of black holes: supermassive, stellar, intermediate, and primordial. We don't need to know the properties of each since all are considered black holes, so we only need to know the basics.
Under NASA's website, black holes are considered cosmic phenomenons, which are still being studied but are confirmed to exist. In 1783, a scientist named John Mitchell first theorized black holes. Black holes are huge concentrations in space with extremely packed matter, making them extremely dense. Due to this, they possess a massive gravitational pull that bends both light and time. This results in the boundary called the event horizon, which sucks everything in. Anything that gets pulled in can kiss their hopes of getting out goodbye.
Black holes also aren't as rare as you think they are. The majority of galaxies revolve around supermassive black holes that are stationed in the center of them. And like most galaxies, black holes spin. They've been observed to spin at 99% of the speed of light.
And time.
Now that we understand what black holes are, we can now get to explaining white holes. A straightforward way to describe a white hole is that they are the complete opposite of black holes, rather than a worse or weaker version of them. Instead, they spit out things that gravitate toward them rather than suck them in.
And since white holes eject things, nothing can enter one from the outside. People also often theorize that white holes could possibly be the exit to wormholes because of that. On the topic of people, we'd also like to introduce a few key people. As previously mentioned, John Mitchell is a key part of the theory. Had it not been for his theory on black holes, white holes would be entirely out of the equation. Also, our famous Einstein played a role in white holes. Science wouldn't exist without math, and with said math, Einstein formulated his theory and equation of general relativity.
Not even a year later, Carl Schwarzschild would find the solution. Thanks to Einstein, the solution of general relativity aided the development of what described both black holes and white holes. Though at the time, white holes aren't a developed idea, 5 decades later, in the 1960s, a Russian physicist, Igor Kokhikov, proposed the idea of white holes and their existence, stating that they were a time-reversed version of a black hole.
Was the previous explanation of white holes not enough? Didn't understand it fully? Or simply want to dig deeper into the concept of white holes? Then this section has a little more complex explanation of white holes.
White holes share the same mass as black holes, so their gravitational pull is equally strong.
But it has a gravitational pull. How does it eject matter?
Think of it this way. Matter has no point of entry in white holes, but always has an exit. White holes are like volcanoes. Volcanoes spew out lava and do not pull lava or other things in. With this example, we can make the steep heights of a volcano the space-time structure of a white hole. Space-time is a concept of physics where space and time are one single entity rather than two. If you think about trying to climb up a steep volcano, success of entry is impossible. Same goes for any matter trying to enter the space-time structure surrounding a white hole. Matter may be attracted to the white hole, but cannot enter. Just like how a human might feel enticed to climb up a volcano, but can't actually enter it.
Oh, okay. Now don't actually go out and try to do that, guys. You only end up in a hot mess. Is this thing on? Anyways, the elements and composition of a white hole are currently unknown since we haven't found any evidence of their existence. But scientists speculate that white holes could also emit radiation and particles like black holes. Scientists also speculate that the Big Bang was a result of a massive white hole puking out all that matter. This is because the Big Bang is thought to have started off as a very dense and hot state, as if something were to be ejected.
White holes are thought to be unstable. If matter were to actually enter, it could throw off the entire flow of a white hole and possibly turn it into a black hole. But there are a few theories that also suggest that black holes could turn into white holes. After billions of years, a black hole will eventually succumb to Hawking radiation, which is Stephen Hawking's theory that black holes emit radiation. And due to all those years spent emitting radiation, black holes will decay, turn into a white hole, and emit vast amounts of energy.
To further support that idea, white holes are heavily assumed to be short-lived phenomena, which makes sense in examples of the Big Bang and emission of vast energy within a black hole.
In conclusion, white holes are the universe's polar opposite of black holes. They push matter away, are short-lived, and have no entry points.
And again, white holes are still considered hypothetical, so don't stay up all night worrying about another Big Bang. And if they actually do exist, we hope this video helped you understand and possibly prepared you for white holes.
Thank you for watching!